All right, subscribers, welcome back to another episode of Science with Surback. Today, what we are going to do is some extra practice on counting and rounding significant digits. Now, this is something that often trips people up or causes some people to be confused, but just remember, we outlined a set of rules in our notes, and all we're going to do here is apply those rules to some examples. So the first thing here, it says determine the number of significant figures in each measurement. Now, in notes, this significant figures can be called significant digits. I interchange those particular names there, and they can be interchanged. So what we need to do here is figure out, by applying those rules, how many significant digits that we have. What we need to start with is the number, and we need to start on the left-hand side of the number, and we need to ask ourselves, okay, is that first number a non-zero number? Okay, well, 3 is definitely non-zero, so that is significant. We ask ourselves to the next number to the right, is 4 a non-zero number? Yes. Then we get to the 0, and this causes some confusion. Zeros sometimes count and sometimes do not count as significant digits. This right here is a 0 squished between two non-zero numbers. So the rules state if a 0 is squeezed in between two non-zero numbers, it counts as a significant digit. So yes, this is significant. We get to the right of that 0. 4 is a non-zero number. It is also significant. And the 3 and 8 are also significant because they are non-zero. So in this case here, we're going to count every digit because that 0 is squished in between our non-zero digits. So in this case here, we would have 1, 2, 3, 4, 5, 6 significant digits. And I'm going to call this 6SF, and SF here is just going to stand for significant figures. And again, you could call that significant digits. It is just counting, again, those numbers that are significant. Now, I want to get to problem 1B, and we're still counting our significant digit here. And so we ask ourselves, we always start on the left-hand side, we ask ourselves, okay, is this a non-zero number? Well, yeah, an 8 is a non-zero number, so the 8 is significant. Same thing with the 7, it's non-zero, so it's significant. And then we get to the zeros. Again, this is where people usually tend to stumble. We ask ourselves, is the 0 squished in between two non-zero numbers? Well, no, it has a 0 to the right of it, and yes, there's that 7, but it is not squished in between two non-zero numbers. So no, this is not significant. We get to the next number here, and we ask ourselves, it's a 0. Is it squished in between two non-zero numbers? No. And the last 0 here, again, we ask ourselves, is it squished in between two non-zero numbers? No. Now, the only way that this could count is something I'll talk about on the end. So the only significant digits we had here were the 8 and 7. So we have 1, 2. That makes 2 significant figures. Now, again, I said, hey, the only way these zeros would count is if we put a decimal at the end of this last 0. That decimal, once you have a non-zero number, makes everything count. But since we do not have that decimal there, we cannot count those 3 significant digits. Okay, let's move on to 1E. And we ask ourselves here, okay, we start to the left. We say, okay, this is a 1. Is it a non-zero number? Yes, it is significant, that means. Then we get to a 0. Well, wait a second. We've had a non-zero number and a decimal. Once we get to this, a non-zero number and a decimal, it is game on to count everything listed here. So non-zero number plus the decimal everything counts. Doesn't matter if it's a 0 or a non-zero number, everything counts if you have a non-zero plus a decimal. So we have 1, 2, 3, 4. So that is 4 significant figures. Now down here on 1F, we start out here to the left. We ask ourselves, 0, is it non-zero? Well, no, it's a 0. So that means we can't start counting significant digits. We have a decimal, but we did not start out here with a non-zero number. So that means that this 0 can also not count. We can only start counting with a decimal after we hit our first non-zero number. Well, that first non-zero number is 4. So that would count, and anything after the first non-zero number in a decimal counts. So our 4, 8, and 3 would count. This would give us 3 significant figures. Now, again, these two zeros, even though we had a decimal, do not count because we have to have a non-zero number first to be able to start counting our significant figures. Now, I want you to do C, D, G, and H on your own for problem number 1. Let's move down to number 2. It says round each number to 5 significant figures. Write your answer in scientific notation. Okay, so with this problem here, we start here with 2A. Again, we need to find the first significant digit. We ask ourselves, is the first number a non-zero number? Well, no, it's a 0. So that means we have to get to a non-zero number before it can start counting as a significant figure. So this is 0. It does not count. Yes, we have a decimal, but we need a non-zero number first. This does not count. This does not count. This does not count. Our first significant digit is this 2. So what we need to do here is this. We need to count our significant digits starting at the 2. And we need 5 of them. So I'm going to start at the 2, and I'm going to count to the right 5. So I have 1, 2, 3, 4, 5. All right? So those numbers, the 2, 4, 9, 9, 5, are going to count as my 5 significant digits. And so what I'm going to do is this. I'm going to keep that in mind, 2, 4, 9, 9, 5. Those are my 5 significant digits. And I'm also going to move the decimal so I can get my answer in scientific notation. So I'm going to start with the decimal. I'm going to move to the left. So 1, 2, 3, 4. We'll count those humps again, but I'm going to write down those 5 significant digits. So those 5 significant digits here were 2.4995. Now, in scientific notation, we have the times 10 business, and we move the decimal from left to right. When you move the decimal to the right, you count the number of humps, and those number of humps is the negative exponent. So we have 1, 2, 3, 4. This means it is times 10 to the negative 4th. Okay? So again, insignificant digits, this decimal here, or excuse me, this scientific notation business does not count into your significant digit count. Only the numbers before the times 10 to the business counts as a significant digit. All right, so let's go ahead. Let's try number 2B together as well. So in 2B, again, the first thing that we need to do is we need to find our 5 significant digits. So we ask ourselves, 9. Is it a non-zero number? Yes, that is our first significant digit. Then the 0, we ask ourselves, okay, how is the 0 significant, or is it? Well, it's squished in between 2 non-zero numbers. So yes, that counts. So that's our second. 7's a non-zero number. Yes, so that counts. And then we get to a decimal. Hey, we've already had a non-zero number, so everything could be considered significant. Okay? Now, what we need to do, since everything is considered significant because we started out with a non-zero number and a decimal, we need to count over 5 decimals. So, excuse me, we need to count over 5 significant figures. So we have 1, 2, 3, 4, 5. Okay, so what we do here is this. Our last significant digit is going to be this 7 to the right. What we also need to do is move the decimal. So we're going to move it 2 humps. And so we are going to write down this. We are going to write down 9.070. Right now, all of those are significant, okay? However, we need to talk about the rounding. And we really need to locate the rules for this rounding. So our rule that we need to use is this. It's rule number 3 for rounding significant digits. It says if the digit to the right of the last significant digit, which in this case, the number to the right is to the right of the last significant digit, is a 5, followed by a non-zero number, then we round up the last significant digit. Okay, so it's a 5. This is a non-zero number. That means we round up this last significant digit. So this would be 0.8 times 10 to the 2 humps. We moved it left. That's a positive times 10 to the second. Again, we rounded that 8 because the number to the right of the last significant digit we want is a 5, and there's a non-zero number. All right? So couple more problems that I want to show you. I want you to do problems 2C and 2D on your own. Now we turn to the next page here. And it says write the following in 3 significant digits. Okay? So the first thing that we need to do is we need to find that first significant digit. Well, we ask ourselves, zeros are not significant if they're out in front, okay? So that means that 0 is not significant, this next 0 is not significant, and then this 0 is significant, okay? Excuse me, I said that wrong. That 0 is not significant. You have to get to a non-zero number first before we can start counting those zeros. So let me correct myself. The first significant digit is this 3. Now, once we have a decimal and a non-zero number, everything is considered significant. We want to round to 3 significant digits. So we would round 1, 2, 3. So let me write this down here. This would be 0.0030. And now we need to talk about, okay, do we round that 8 or not? Again, let me turn to our rules, and I'm just going to read them directly from notes. It says this: if the digit to the last significant digit is a 5, followed by a 0, or no other number at all, look at the last significant digit. If it is odd, round up. If it is even, do not round. Okay, so last significant digit is this 8. We get to a 5, and then it says it's followed by a 0 or no other number. We look at the last significant digit. Well, an 8 is even. So that means we do not round up. So this would be 0.00308 kilometers. Or if you want to express that in scientific notation, we could take 0.00308 and you press enter. We put that in scientific notation. That would be 3.08 times 10 to the negative third kilometers. Okay? Now, I want to do one more problem. And that is problem 3C. So, again, we have to find our first significant digit. Well, we ask ourselves, 5, is it a non-zero number? Yes, that is good because that means that is our first significant digit. So then we just count 1, 2, 3. Our last significant digit would be this 0. To the right determines if we round it. Well, it's greater than 5, so that rounds up. So this would equal 5010 milliliters. All right. Or again, if you want to express this in scientific notation, 5810. expressed in scientific notation would be 5.81 times 10 to the third milliliters. All right, so again, utilize your rules that we have in notes. Be able to count and then be able to round. There's a lot happening. There's a lot of rules that we've talked about in notes. Utilize those rules to help you out with this particular worksheet. Again, any problems I did not do, you need to do on your own. I hope you have enjoyed this episode. And as always, if you haven't already, make sure you subscribe.